at a geometric series, which again is the sum of a geometric sequence up to a certain value. So as long as we know what our A, R, and N, and T and N equal here, then we can essentially work with either of these series or these sums of the entire series. So again, our A value, you remember what that stands for?
That is the first number of term, the first term.
Exactly. Okay. What about R? R is?
I don't remember.
If not, okay, that's okay. I'll give it.
Common ratio.
Yeah, that's right. It's the common ratio. So what it's being multiplied. You could technically say divided by, but when we're talking about division, they usually just say what fraction it's being multiplied by. So 1 over a value is kind of still like division. And then the n term is our numbered term. So whatever term we're talking about. Okay. So with that being said, that helps us. All we need is an A, an R, and an N, right, for our geometric series. So these are two formulas. They are the exact same, just one has been factored differently than the other. They give you the exact same thing. So really, just memorize one. It doesn't make any difference at all. Okay. So we've been given two questions here. And the first thing we're going to do is decide, is it arithmetic or is it geometric? If it's arithmetic, then we're not going to really deal with it. We just want to be able to tell. So what we need to do is figure out what it's changing by. Is it a ratio? Is it a difference? What's happening here? Well, we're going from the number -18 to 15. There could be division in that, and one way we could find out, because it's clearly going to, well, the absolute value of it at least is shrinking. Okay, so if we were to multiply, we'd have to multiply by a value that's less than 1. Okay. So in order to figure that out, what you could do is you could take -15 and divide it by -18. And we get 0.8333. So there's a possibility that's what's happening. So let's kind of write that down. So we're being multiplied by 0.8333. And you can figure out as a fraction by just saying -18 over -15 and reducing the fraction. Both are negative, so it becomes a positive value. And 3 goes into both of those, and it would actually be 6 over 5. Did I write that in the wrong order? Oh, I did. Sorry, we should have that flipped. Let's do 15 over 18. Because 6 over 5 would be a number greater than 1, and we're not growing. Okay, so we're multiplying also by 5 over 6. Okay, so let's try that again. 15 times 5 over 6. So 5 over 6. Lost the part there. Gives us 12.5. Is that our number here? No. What if we were to add or find the difference between the two? What's -18 subtract -15?
2, which is 2, and then it goes 3 between 15 and 12. So
yeah, well, it goes. This is actually an increase of 3. This is an increase of 3. Oh. Yeah, so it's going up by the same amount. So this is actually an arithmetic one. Okay, and after a while you get pretty good at telling which is which. Okay, so and that's one way to test it. You take this value and divide by the other one, and that would tell us what our common ratio is. But the ratio wasn't the same between them, so therefore it can't be geometric. This one you can do the same thing. Okay, you take this value, divide by this, and we're dealing with fractions. It gets a little complex, but I'm going to tell you what's happening. I can tell already.
Bottom's multiplying by 3 to the number, and the top is multiplying by 2 to the number.
Perfect. This is being multiplied by 2 on top. This is being multiplied by 3 on the bottom, which means in whole what's happening is the entire fraction is being multiplied by 2 over 3. Okay, and again, the way you could technically figure that out is you take this term, term 2, and term 1, and you can divide them. We divide term 2 by term 1, and that will give us our common ratio. So we'll quickly show it. 2 over 9 divide 1 over 3. When we divide fractions, we invert and multiply, they usually say. So multiply and you flip. So this becomes 6 over 9, which reduces to 2 over 3. So there we go. We have our common, our R value. Okay, so that works out good. What color was I doing? R in blue? Okay, so R value, 2 over 3. A value is just the first term. A value is 1 over 3. Here's a tougher question now.
What is our N?
What is what is our n value? They haven't told us. What they've told us is just some term. And we don't know what it is. So what we're going to do here is we're actually going to use our geometric sequence to figure out our n value here. Okay, we know what the term number is. They've told us what it is. Our t at n is this 64 here over 2187. So we have 64 over 2187 is equal to the a value, which we said is 1 over 3 times the r value. R value is 2 over 3 to the power of n minus 1, is it?
Yeah.
Yeah, n minus 1. Okay. And I think I use green or something like that. All right. So, first step here is we need to somehow isolate for n minus 1. So we're going to have to use some logarithms probably to do this. I want to move this 1/3 over to the other side. So I take this guy, and when it comes over, we divide by 1/3. That's actually the exact same thing as multiplying by 3. Okay? So if you took your calculator, you could do it, but I'm just giving you a little shortcut. It's the same thing as multiplying by 3, so we're just going to multiply by 3. And that, I'm going to tell you, is going to be 2 carry the 1, 192 over 2187. Okay? Still is a fraction. We could technically convert to decimals, but were you okay with that?
Yeah.
You already did? Okay. So now we're equal to 2 over 3 to the power of n minus 1. Well, we need to bring this exponent down. So we're going to take the log base 10. Okay, we're going to take log base 10 of each side.
Yeah.
Okay, so we get log of 192 over 2187 is equal to, when we take the log of this side, the exponent can come down, right? So log of 2 over 3. And the exponent comes down, it's multiplied in front. We have n minus 1 multiplied by that. We need to isolate for n minus 1. So I got to divide by log 2 over 3 on the other side. This is kind of a complex question. Log 192 over 2187 is all going to be divided by log 2 over 3, which will be equal to n minus 1. So this is something we could do on a calculator. Does my lovely calculator do it? It does. Great. Log base 10 of, and it already gives me brackets, so I could put fractions in. 192 divide 2187. I'm going to do this all in one shot, and all of that is going to be divided by log base 10 of 2 over 3. 2 divided by 3. I need 2 ending brackets. Value is 6. That's wonderful. Very nice number to work with.
Yeah.
And n minus 1, I bring 1 to the other side. That gives me n is
5.
sorry,
yeah,
7
no,
because it
7,
becomes
yeah,
addition. Yeah.
Yeah.
Okay, good. So now we have, finally, after all that work, our n value, which is 7. Now we can finally plug it into our series here.
So just quickly, you chose to do log 10 just...
Our geometric series here. I'm just going to steal the first one. Like I said, they're both just versions of each other. So I said n is equal to the a value times r. I think I did r is blue. To the power of n minus 1 divided by r minus 1, I believe. I'm going to double check that by flying up the page. Yeah, that's it. Okay, and our values are a is 1/3, r is 2/3, and n is 7. So let's plug them in. A is 1/3, r is 2/3, n is 7, so it's 2/3 to the power of 7. So you could almost put, and if it's easier to look at, you put that whole thing in bracket there, minus 1, divided by 2/3 minus 1. So you can work with a whole bunch of decimals, or you could work it all out. It's really up to you here. Now this one's going to be a tougher fraction to work out. I actually know what 2 to the power of 3, or sorry, 2 over 3 to the power of 7 is. It's whatever this number is. We actually kind of just figured that out. So I'm going to try playing with this. 192 or 2187. The reason I'm going to do this is I'm going to try to get a fractional answer. You can use decimals, okay? So 2 to the power of 3, or sorry, 2 over 3 to the power of 7 is equal to 192 over 2187, Okay, so
You
I'm
just
gonna.
distributed it, right?
Well, yeah, it's exactly what I did. I did 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3. I did it 7 times. Okay, we still have a third up
Didn't you
here.
have distributed the 7 to the 2 and then the 7 to the 3?
Yeah,
So
it does the exact same thing. If you do 2 to the 7th, you get 192, and 3 to the 7th, you get 2,187.
Okay.
Exact
Yeah.
same thing. And then this subtract 1 is actually going to be 1 as that fraction is 2187 over 2187 subtract 192. Yeah, so really it's that value subtract 192. You're going to keep our base as 2187, and we'll figure that out. And again, I'm just trying to be fractional so we can be very, very exact with our answer here. 2187 subtract 192. 1995. All right, a little easy to remember for me. 95. And 2 over 3 subtract 1 is negative a third. Okay. So we have negative a third. Okay. So I already know it's going to be, we know that this here, yeah, is going to be a negative value. I'm going to pause for a sec. And actually, I kind of made an error here. This number is less than 1, so when we subtract it, it should have actually also been a negative. Okay, so just because I was a little worried, I'm like, we shouldn't be getting a negative answer. Okay, so what we could do is we can multiply this and kind of work out our fractions, and that'll work nice. Another thing I can do is, I know a little shortcut here. I know I have a third divided by negative a third. I can actually just deal with that first, okay? And we invert and multiply. So I'm using my fraction rules to help me out a little here. We get negative 3 over 1.
3 over 3,
Negative 3 over 3, which is negative 1. So now I have negative 1 times this fraction.
The fraction just stays there.
Yeah, and the fraction just stays the same. So it saved me a lot of fractional work there. And a negative times a negative is a positive. So the sum of this is 1995 over 2,187, which as a decimal, we can calculate if we need to, 1995 divided 2187. 0.912, blah, 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 blah. Okay? Which is very possible all the time. This 2 to the 7th is not 192, it is 128, which does change some stuff. Okay? When we subtract it, we don't get 1995. What do we get? 2000.
We get 2059.
2059, which now means, we correct a bunch of these, this is 2059, which means our final answer is 2059 over 2187. There you go. So
Yeah.
that one's smaller, but everything else is the exact same.